Hey everybody, Mr. Troy here. It is time to take the candle of knowledge and set your brain on fire. Wait, no, hold on. Don't set your brain on fire. And only use candles if that's... It's time for math with Mr. Troy. But seriously, about the candle thing, like, only do that if you've parent permission, be safe, all that good stuff. Okay, I'm not, like, extinguishing the candle of flame of knowledge or anything. I just want to be safe when I'm recording the video. You know what I'm talking about? Okay, this video is about function inverses. It's our last video from our first unit of study. So we got a definition here. Two functions are inverses of each other if their inputs and outputs are swapped. So what you will see in these two tables are some inputs and some outputs. And of course, over here, those are swapped. So in a table, you would see the two columns transposed. And if you were just talking about the coordinate points, you would see individual x values and y values transposed. Now, the way that I know that the left table here is a function is because none of its x values are reused. So there's never a time where one input has two separate outputs. This one is a function because its x values are also not reused. That is very important. So just taking the inverse of something does not guarantee that it would necessarily be a function itself. So another way of looking at it is by looking at points. So two functions are inverses if their inputs and outputs are swapped. So this graph has the point 4, 0. If this graph is to be its inverse, it would have to then have the point 0, 4. So for inputs and outputs, think x and y. For example, here, if this has the point 12, 2, then somewhere up here we would have to have the point 2, 12. The description of what's happening here is that points are being reflected over the line y equals x. So points are being reflected over the line y equals x. What you will notice here is that I took this red function and I reflected it over the line y equals x to get this blue function. Both of these are functions because both pass the vertical line test. Now, just because something has an inverse doesn't mean that its inverse is necessarily a function. So for example, this red graph can be inverted. All of the x values and the y values can be switched. So 0, 1, 1, 0. Negative 1, 0, 0, negative 1, and so on and so forth. But that doesn't make this blue graph a function. The reason the blue graph isn't a function is because it doesn't pass the vertical line test. Now, you can tell ahead of time if a graph's inverse is going to be a function. This graph's inverse is not going to be a function because it fails the horizontal line test. So the horizontal line test is new to you. It's just like the vertical line test, but it tells you if it is going to have an inverse that is a function. Now, because this graph fails the horizontal line test here, its inverse would fail the vertical line test here. So whatever this y value is, where it fails the horizontal line test is the x value where its inverse would fail the vertical line test. The name for this is a one-to-one function. In order for a function to have an inverse that is a function, it has to be a function, so it has to pass the vertical line test, and it has to pass the horizontal line test. So the way that we summarize that is we say a function is one-to-one if every input has exactly one output and every output has exactly one input. Go ahead and pause the video and write that down, and then I'll explain this picture. So here's the deal with this picture. If I ask you, what is the y value when the x value is 5, you would say, oh, well, there's where x is 5, so what was its y value? Oh, 4 point something. If I ask you what x value gives you a y value of -1, you would be able to say, oh, right about there, because I can see that y value of -1. So this is called one-to-one because every input will tell you a particular output, and any output gives you a clear idea of what the input was. Let's contrast that with our earlier example. If I point out on this red graph the x value of -2, you can tell me what y value that has. However, on the red graph, if I say, what is the x value when y equals 4, you would be forced to say, well, there's actually 2 of them. And that is why the inverse would not be a function. Finding an inverse graphically is relatively simple. All you have to do is switch x and y, and that will have the effect of reflecting about the line y equals x. So let's start with some of the more challenging points. This is -3, 1. So its mirror point would be at 1, -3. This is -1, 1. So its mirror point would be at 1, -1. So can you see how this line segment is reflected? So then we've got the point -1, 4, which would be reflected to 4, -1. And 1, 4, which would be reflected to 4, 1. So we're just switching the x values and the y values. And then when you look at that, you can see that that is reflected over the line y equals x. So doing this algebraically is actually pretty much the same thing. You're going to write your equation as a y equals and then you're simply going to switch x and y. And that's all you have to do to find the inverse. However, we almost always want to give our answer solved for y again, because that's what we're used to seeing. We're used to seeing equations that are y equals, not x equals. So, for example, on this problem, I would have x minus 3 over -4 as y. And then the way that we write that is with a special symbol. So we write it as f inverse of x equals negative x minus 3 over 4. So two things. F inverse is just the symbol that we use to say here is a function that is an inverse of f. And then the other thing is I don't leave my negative in the denominator. I put it out front. Okay? Okay, so one more time, write in terms of y and x. Then switch x and y. Then solve. Now, depending on what your purpose is, sometimes you'll need to multiply something like this out. So for example, the next step to undo the cube root would be to cube both sides. And depending on what your reason for doing this type of problem, you may have to multiply that out, you may not. In this case, I'm going to choose to not multiply that out because my focus here is on finding an inverse function, not using it in some particular way where it needs to be simplified. So once we've got it solved for y, we're going to write it as f inverse of x equals 2x minus 4 cubed plus 1. Okay, so I want you to try problem number 3, and we will pick that up when we talk to each other. Thanks for watching, everybody. Hope that was helpful. Have a great week.